Men. And once again, I use the term loosely. In the first video of this series, this cart was full of parts from a 59 XLH that came in from France. Most of the parts have been moved. Most of the parts are piled up on my lift now. The difference between when the parts are on the cart and now that the parts are on the lift is that I spent many hours cleaning, sandblasting, power washing. Anyway, the prep work on most of the stuff is done. Most of it could be put back together again. Down on this end of my lift, I got a whole pile of new parts. A partial order came in, so it's getting close to reassembly time. The one thing I need that I don't have is a crank pin. So when I get a crank pin, I'll be able to put it back together again. But let's look at some of the findings. Okay, this is one of the flywheels. And the thrust washer, crank pin thrust washer is kind of dicked up. So I popped it out of there. And a lot of the time you could just flip them over and use the other side. Well, when I flip this one over, look what I find. The other side is totally chowdered. A great lot of overheating, so there was a problem there. And you know what? There still is a problem. The rods. There was very little free play side. Well, some people call it lateral chuck. There was very little side play in the rods on the pin. They weren't binding on the flywheels, but very, very close to binding. I could not move them back and forth at all. So, you know, the play was probably 1/1000th of an inch or less, I would suspect. I got a new crank pin on order. There's a little variation in crank pins. Some are a little longer, some are a little shorter. The tapers fit differently, and I'm hoping that when I put the new crank pin in here and tighten the nuts down, there will be free play on the rods. If there isn't, I'm going to take the female rod out to the milling machine, and I'm going to mill a few thou off of this face. Alright, I'm going to show you the initial transmission evaluation I do on them. Make sure it's in neutral. And the first thing you want to look at is the clearance between the shifter dogs and the adjacent gear. There is a spec on it, and I don't remember offhand what it is, but initially what you want to look at is to make sure they're about even. And you want to make sure there is clearance there, a good clearance there. Because if you don't, the dogs will hit the gear and it'll beat the corner off of the dogs and fuck up the gear. To correct improper spacing, the shifter forks come in plus and minus lengths so you can move the gear back and forth. Anyway, this is the third, fourth shifter, and it looks okay. Flip it around the other side, and this is the first, second shifter dog, and that's got a good clearance in it. This has got a good clearance in it, so it looks okay. When you take it apart, which I'm going to do here in just a second, you need to look at the shifter forks, of course, to see if they're jacked up. But the other thing you want to look at is to see if they're stamped with an oversize on it, because if this one is a plus 20, you need to put it back where it came from so that it'll be a plus 20 when you're done. All right, let's pop the main shaft out. Let's pop the shifter fork shaft out. Sometimes you gotta tap them a little bit, and you could get to the shaft to tap it through this hole. Usually they're not extremely tight and they come right out. So you could get this out of there. Shifter fork will come out. Sometimes there's a number over here. Sometimes there's a number up here. Anyway, check and see if it's got an oversized stamped on it. This one does not. The wear surface looks good over here. The wear surface looks good over here. Really, this one shows barely anywhere, so that one's good. Okay, the trans is in neutral, and when it's in neutral, this shifter fork doesn't want to come out. So what you got to do is line the dogs up so you could slide it into second gear. Then the shifter fork comes right out. And once again, wear surfaces actually look pretty good. Look pretty good over here. So this fork is probably good. There's no oversized stamped on it here, no oversized stamped on it there, no oversized stamped up here. So these are standard size forks. When you get that out, the whole countershaft cluster comes off. So this fucking bearing, excuse me, this bearing is fucking horrible. It's smooth, but man, there's a boatload of play in this thing. This is rocking all over the place. So this bearing needs to get replaced. Somebody, let me get you in close to look at this dick up job. Okay, this is the clutch gear. This is an expensive piece. Somebody has just beaten the shit out of the end of the shaft. If you're going to run the dry clutch, which is what I plan on installing in this thing, there's an O-ring that needs to go into this groove that has been totally obliterated. Do yourself a favor, don't beat on your parts, otherwise you'll be changing them later on. So he's getting a new one of these. He's getting a new bearing that it goes in. The springs, which are in the pawl, I just replace them usually. You know, these things are, let's see, it's a 59, so that's 56, this is 64 years old. These springs have been in there for 64 years. So he's probably getting a new set of springs. Trapdoor, I don't see any problems with. This is the gear that engages the clutch gear. So this is main shaft second. I'll get you in close on this one too. Notice the corners knocked off of the shifter dogs. So that's getting replaced. The other two main shaft gears both look okay. This bearing surface, if this bearing surface is dicked up, you got to buy a new shaft. These shafts are also very expensive. But this one looks okay, so it's going to get used again. Countershaft cluster. Low gear. Low gear looks real good. Countershaft third. The dogs look real good. Almost perfect. Very close to perfect. Teeth are all good. Countershaft second gear. Where the dogs engage, all look pretty good, so that's okay. Bearing surface over here looks okay. And the countershaft drive gear, which should come off, but it isn't coming off easily. But I really don't need to get it off right now. Looks good. There's no dogs on this one. This is the countershaft drive gear. Bearing surface looks good, so countershaft is good. So he's made out okay so far. This could have been a lot more expensive, but it's not too bad. Just FYI, 74 and later have two of these washers. And just another FYI, so far as I am aware, this countershaft low gear with the Speedo drive is not available anymore. There are, of course, used ones and eBay ones floating around, but you can't buy a new one, so far as I'm aware, unless you find a new old stock one. You can use the ones without the speedo drive, you just got to be careful of your, your thrust washers that go down in here. And when you use the one without the speedo drive, you'll need another thrust washer over here. And these washers are available in different widths. And the width of this washer also helps control how much of the dog engages with the gear. So anyway, that's it. So this trans has got some expensive stuff on it, but overall it's not too bad. I've seen a lot worse. Kickstart shaft. The threads are all dicked up, so he needs a new shaft and a corresponding new nut. Okay, clutch hub nut. Lovely piece of work. This is getting replaced. Once again, people, go buy the wrench. Chisels, hammers, they only get you so far. Yeah, go buy the socket. 1.5 inches. Works wonders. Clutch springs. I'm not quite sure what the problem was that the previous owner was trying to solve, but 2 different length springs. When the bike goes back together again, it'll have stock springs all the same length. Once again, these springs may have been compressed for 50 years. Some stuff you should probably just replace because, it can't be good, like for a spring to be locked in the same position for, say, 50 years. Anyway, new spring, stock length, stock clutch. Not much to say about that. Pistons, yeah, they're toast. So having gone through that little gyration, that leads to the question, what is the project of the day? Well, I'd like to put the flywheels together and get them trued up, but I can't because I don't have a crank pin. So the brass tube stock arrived, and I think we're going to make some brass pushrod covers. That'll be next. Alright, I got the brass tube. I'm going to make the lower pushrod covers out of chucked up over here. Just going to square the end up to get started. That's pretty easy. Alright, I need to lop off 4 of these, the same size as the lower tube. Okay, here's a consideration or a problem, depending on how you want to look at it. This tube, the outer lower tube, is 0.32 thick. That does not give a lot of purchase for the tube to seal on the cork washer on the bottom or the cork washer on the top. So what I want to do is cut some 1-inch wide rings out of a piece of thicker stock, slip it over either end, and solder them in place. Theoretically, this tube should slide into the other tube, but it doesn't quite. I could probably knock it in there. But what I think I'm going to do is go in here with the boring bar and shave a couple of thousandths off so that there's room for solder to flow. So I'm going to put my longest boring bar in there, do as much as I can, cut off, a couple of 1-inch hunks of this because I'm going to have the sleeve is going to go up about 1 inch, and I'm going to drill some decorative holes around it on the bottom and on the top. I got the boring bar set up to peel a couple of thou off the inside of this tube. Okay, here's the plan. I've got 4 of these brass tubes. These are the lower pushrod covers. Onto the 4 tubes, I'm going to solder 2 collars. One at the top, one at the bottom. Before I solder them, I'm going to drill a series of 6 holes around the periphery. The plan is to heat them from the inside, put the solder in through the holes, and hopefully it'll wick around the whole thing and, firmly solder it together. The holes are there partially for soldering. And I think I could do this like a guy sweats a pipe, where I just feed it in the end. But I want to put a little decorative element on there. And the 4 holes with a, a bead of solder showing is just going to, a little decorative element is all it's going to be. When I get it all put together, I'm going to have to turn a few thou off of this diameter and a few thou off of this diameter to get it to fit into the spring cup and to get it to fit into the lifter block. So I'm setting up on the mill right now for drilling the 6 holes. Alright, I got one of the collars set up in a collar block, 1/2 inch sticking out. I'm setting the collar block even with the side of the drill press vise. The collar block is centered. I use my LED edge finder to find this, the center between the 2 jaws of the mill vise. So we're all set up, should be ready to go here. I was going to center drill them all, but I tried one without center drilling it, and the drill, went in straight and it didn't really wander. So I think I'm going to skip that step just to save a little hassle. And 1 done, and 7 to go. Yeah, that worked out pretty good. Alright, we're going to start soldering these collars on. I happen to be using MAP gas. Propane would work fine, but I'm out of propane, so MAP gas it is. And actually I did one, and it's surprisingly easy. All right, looks like it's solidified. And that's that. 4 more to do. All right, we're getting close to wrapping this up. I've got to machine this outside diameter on both ends down to 930 thousandths. So the spring cup will fit over it, and so that the bottom end will fit into this pocket on the lifter body. Got 50 thou to go. All right, there we go. Seven more? Yeah, 7 more of these ends to turn down. I've been protecting the brass tube with a Pepsi can. Okay, and here's one of the spring cups. Fits over there nicely. And the well down at the lifter body fits over there nicely. So, yeah, this is good to go. All right, and these tubes are going to get the same satin finish polish job the nuts got. Okay, here's going to be the last step in the process. I gotta make the clips. You could get on the internet, and there's several places that sell brass clips with, holes drilled in them, or plain brass clips with no holes and no little thing on it to pop them out. They're kind of pricey. So anyway, what I have is a piece of brass tube that I made the lower covers out of, and a clip. What I'm going to do is vice grip the clip to the brass tube and use the clip as a cutting guide. It doesn't have to be tight, and you don't want it too tight, because if it's too tight it will distort the tube. So we'll just clamp it up in the vise, and we'll use a Dremel tool. I move the clamps around to move the vice grips around to the other side, and then we'll cut the other half off. And there you have it, 2 clips. I'm going to file these edges a little bit, run it out to the buffer, and those will be done. And there you have it, the finished project. A couple of things I had to do that I didn't video. Of course, when I machine these diameters down, it smeared the metal across these holes. The other thing that happened was when I soldered these, the hole on the bottom, or the two holes on the bottom, you know, the solder flowed all the way around and it filled those holes up to the top and then some. So, you know, I machined these all down, which of course took off the extra metal, and it smeared the brass over these holes. So I got these are 1/4 inch, so I got a 1/4 inch drill bit, and just in the drill press, I lined up on these things by eyeball. And there are several reasons I didn't do it on the milling machine. You know, ideally I would have put it back in a collet block and just around, you know, go around. But I didn't have, you know, the collet block, you know, couldn't fit over the smaller middle diameter because the ends were bigger. I didn't have a collet block the same size as the ends, so I just did it in the drill press vise. But anyway, I took a 1/4 inch drill and just drilled down into here a little tiny bit, lining up on the old hole, and that cleared the burr off. And on the ones that the solder had filled up, it had taken the solder down. You know, so there was actually a hole instead of a solder plug in these things. Anyway, I'm very happy with the way this turned out. It took, you know, I work at a leisurely pace, but you know, it took a day. And you know, when I get into, you know, the owner didn't specifically approve this. He just said he wanted as much brass as possible. So on other projects I've done, if something seems interesting to me and it seems like something I might do, I'm going to eat a tremendous bit of this cost. I can't charge him, you know, for all of the time for something he didn't authorize and might not want, might not even like. But, you know, this is what he's getting. He wanted brass, he's getting brass. The only part, well, you can't buy solid brass lower covers as near as I've been able to find. The part where he made out ahead on those, the clips, these clips were really pretty quick and easy. You know, I don't know, 40 minutes for all 4 of them. And a set of these bastards is $44, $46, which is pretty pricey for a, you know, a piece of brass tube cut in half. I made the clips a little shorter than the HD ones by about 1/16 of an inch. And you know, if you've taken these in and out, that sometimes they really could be a bitch to compress the spring and shove them over. I did buy brass spring cups because I didn't feel like making them. And the cup, the bottom of the cup should come down to about here. And of course the lip on the tappet blocks should come up to about here. So these should be pretty symmetrical height-wise as far as how much of these little drilled holes are exposed. But anyway, that's done. With that, I am out of here. And the usual caveat supply. Get yourself a sticker. Get yourself a coffee cup. Join me on Patreon if you feel like it. Thanks ever so much for watching, and we'll see you later.